Hello, my name is Bartee III, and today I will be talking about heat sinks. As someone who aspires to be some type of engineer, I like to deal with electronics. I knew before working on the project what heat sinks were and decided to delve deeper into what they do and how they work.
A heatsink is something that spreads and moves heat created by a mechanical or electrical device to counteract overheating. They're usually in things like computers and are connected to a CPU to help it cool off. To test the heat sinks, I'll be placing an ice cube on top of the heatsink and see the differences between the melting times. This is the first prototype. As you can see, I understood what I needed to do, but I executed it very poorly. I knew that it needed fins which increased the surface area and in turn made it so more air would touch the ice cube and help it melt faster. It still helped melt faster than just being in room temperature by a couple of minutes. This is the second prototype. I tried using the nuts and bolts to make it more compact, but when I tested it, it had two flaws. One, the copper was bent up and not flat, and two, the screws were too tight, which caused the fins to come close to each other, which lessened the airflow by a lot. These things in turn both caused it to melt around the same time as the first prototype. Before I show you the final product, I'm going to go over some of the parts and what they're used for. I use copper as the fins of the heatsink. I used it because they have one of the highest thermal conductivities of the elements, which makes it so if designed properly, it is able to draw cold from the ice. Aluminum is a thermally conductive metal. Not as much as copper, but it is up there. I use it as the base for the heatsink. Its job was to draw out the cold from the copper fins, who have more to go after being drawn from the ice. This makes it so the fins can keep drawing out the cold. This was the only thing that stayed the same for all three of the prototypes. I didn't use nuts and bolts for the first prototype because they didn't have any thermal conductivity. This is because they are made of the non-conductive metal steel. In the second prototype and the final product, I used them to connect each of the fins together so it could stand on its own without having the copper to be bent. This is the final product. It works by you placing an ice cube on top of the copper fins. The fins draw out the cold from the ice, which causes it to melt faster. The cold is then transferred to the aluminum so the copper can draw out more cold. It is faster than ice just melting because the heatsink has a large surface area, which makes it so more air can pass through. Screws make it so there can be more fins in a compact area. Out of everything I have made, this is the best product. Thank you for watching my heatsink presentation. I hope you enjoyed. Bye.